There we go. So, this is the first official attempt at doing a reading group. Uh, the last one I did over the summer was just sort of a feeler to see. You weren't in that one, were you? The first one?
No,
Yeah,
no.
yeah, the first one. I was actually surprised. Like, I reached out and I got like 20 people to show up, but I think because it was new, I think
Yeah.
people were like just sort of seeing what it was, and I ended up picking a paper that was probably not technical enough to keep a lot
People
of,
excited. Yeah.
well, yeah, not so much that, but I didn't walk away from that paper going, oh, I need to look into this, right?
Mhm.
Uh, but their follow-up paper, I think everybody in that group actually found their follow-up paper in the references, which was actually way more technical. So I'm trying to figure out, what's the best way. But first, thank you for showing up, so I have someone to discuss this with. I'm hoping I can do this every month, and I want to work
Yeah.
through the ACM papers actually, that because there was that workshop
Yeah.
um just last month, right? And so I think looking over the proceedings for that, there's a good number of them. In fact, even the ones that aren't open access are actually freely downloadable. So
Oh. Oh,
we might be
nice.
able to
Okay.
discuss all of them uh
Okay.
over the course of like a full year, right? So because I think
Yeah.
there's at least 12.
That, yeah, there's enough every month once. Yeah, that should work.
So and as an extra thing, I might start reaching out to the first author of these papers ahead of time and see if they want to join, so we can actually discuss. Because like in this paper specifically, the reason why I picked it first was because I used to do IoT development,
Mm.
not the actual
Uh,
microcontroller, but I did some of the backend work in like two 2 gigs ago, right? I worked for a startup that did
okay.
that a wearable telemetry device, like a personal device, for personal telemetry. And I found the idea of trying to do something with eBPF in a microcontroller really fascinating, right? Because we think about it as,
Mind-boggling. I read this paper.
yeah,
What?
yeah, so we think about because we I think about it as like it's firmly entrenched in Linux now, and it came over from BSD, right? But not eBPF,
Mm.
but just the packet filter stuff. But the eBPF design, like fully entrenched as a Linux kernel technology, and now it's we're on the cusp of starting to see it show up in Windows for real, right? Because it has a implementation. It's just that the Windows dev cycle is like sort of a little slow, so it's not
Yeah.
going to be in the
How's
wild
that going,
just
by the
yet.
way? I've been kind of watching the Slack channel from time to
Uh,
time.
I keep my eye on it.
Yeah.
Uh it's fascinating, but I just think that I don't think because they do so much in-house development
Yeah.
before they it hits a public beta, right? So
Mm.
I'm I am intrigued because there's so many interesting issues like how it complicates the space, especially because of the licensing. I'm very interested to see how the licensing is going to work out there,
Yeah.
right? Because
Yeah.
I'm
It's
actually
like GPL. Like, yeah. Okay.
Yeah,
Uh,
yeah, exactly. It like,
yeah.
in fact, I'm actually giving I my talk out accepted for QCon, which basically was like eBPF licensing in CNCF because
Okay.
GPL is exceptional, right? And
Yeah.
that's changing. They actually got officially. I don't know if they've made it official, but there was a commit in one of the issues for not Cilium, but I think for Kong. They
Mm.
they were back and forth about the licensing, and it all got sort of cleared up, a lot of upper level governance conversations, but it's clear that it's now going to be rolled out as an exception, a blanket exception. And but it's an interesting topic to talk about, right? Because it's a
Okay.
wrinkle, right? It's not for the CNCF, it's a huge wrinkle, right? Because they don't the GPL is generally not accepted.
So,
and
yeah.
and
Yeah.
now for and very, very soon for eBPF, GPL will be blanket, like it's an okay thing to do for your eBPF, the kernel, the bytecode side. So
Yeah.
anyway, but yeah, exactly. Like, but that
Mm.
issue is like now we start seeing other implementations of the virtual machine that isn't GPL, or maybe it is.
Yeah.
I don't know what the I don't. Well, it can't be for the Windows side, right?
Yeah.
But
Yeah.
it's crazy, right? Like there's, and I know there's runtime. There are user space runtimes to mimic what the for the verifier and the operation, right? To
Mm.
mimic what the kernel does. Um, and in fact, I think this paper uses one of those existing user space runtimes and basically
To verify.
re-implements, yeah, for the verifier, right?
Yeah.
Or it's fascinating, but we'll get into this paper, right? So
Yeah. Yeah.
I when I was reading through it, I did some highlights, and this is like I'm actually
Okay.
hoping that as we do more of these papers, this is how I plan to make notes because I don't want people to like I don't want to read I don't want to spend 8 hours trying to deep dive on the paper. The idea is supposed to be skim it, make some notes,
Hmm.
and then discuss it, right? And like I said,
Yeah.
if I can get the authors in on the discussion, that's even better. But I'll work towards that. Uh
No, it's good. Yeah.
yeah, so for me, the big thing in the abstract is like I got to remember why I highlighted this, right? Because I did it like 2 weeks ago. Yeah, so it seems like the use case for this, for using eBPF here, really is about deploying updates for functional logic for these microcontrollers. And I know when I was doing IoT, Bluetooth low energy device, every time we needed to put this stupid thing in a diagnostic mode, like we had to basically ship like a special over the air diagnostic for effectively a firmware,
Module.
right?
Yeah. Yeah.
Yeah.
Yeah.
And there's a whole suite of like logic just to do that so you can flip flop and make sure it verifies so you don't brick. I
Hmm.
mean,
The device. Yeah.
you can still brick the device,
Break
but
it,
you try
but at
very,
least you
very
can
hard.
override. Yeah.
Yeah, you try very, very hard not to because these things now don't have a full data line. They just have like power pins now, right? A lot of these devices, like they
Right.
require Bluetooth. Like once they're in the manufactured packaging, you don't have access to the GPIO like
Hmm.
pins. Like we could crack if we ever bricked one, we could crack the package and
Yeah.
actually
So
get do a full
it
firmware
works.
reset, right? But once they're manufactured, you have to update these things and you don't expose the pins, right? Because a lot of
Yeah.
this stuff has to be waterproof, which means they're just power pins, right?
Yeah.
Uh
Yeah.
just two. You don't see a full suite of data lines anymore for a lot of this IoT stuff. At least the ones I worked on. Like clearly some of the targets for this is more like edge IoT, which is more like
Yeah.
control
Network.
system
Yeah. Network.
or
Yeah.
yeah, so it's not as complicated, but they do talk about in this a
Yeah.
lot of BLE over the air updates. And it's like the one thing I wish I understood more was specifically the use case they're really targeting here. Like is it really uh just about doing the over the air updates efficiently or
But it sounded like they say some of the examples at the end of the paper where they show what they wanted to do with this show like they wanted to debug something, right? Some device,
yeah, yeah,
something's
yeah.
not working, and they're like, well, how do we deploy now a program that's just not going to disrupt the the IoT device? It's you know going to run, collect some data for us. We're going to extract that data somehow, um, and we're going to ship it for somebody to know. I think it's further up. I think they have really nice. Yeah, well, a little bit more, a little bit more, more. Before this performance evaluation. Yeah, and one more. Yeah, I think it's here. So they have an example here what they were doing. And it seems like they hooked into a thread switch
Hmm.
and they were counting each time the thread changed context or something like that.
Oh yeah,
Um,
in fact, I think this was their example of a hot path, like the thread switch, from a
yeah,
like this is sort of like a worst case scenario. Like
scenario.
you can
Yeah,
yeah, you can debug things, but if you debug this, this is
yeah,
the
that's it. End of. Yeah, that's it. You're
like
taking down the device.
right, because it happens so often that uh you end up running this other the little eBPF program all the time. In fact, the performance, like but I even thought that was actually amazing performance. Where was they had a table on the,
Yeah, that's about
yeah.
the sizes. Uh, yeah, there's yeah the the hook is about 100 cycles, they said.
Hmm.
Uh, but
But
the
the hot code path ended up being significant. But anything that was more like just business logic diagnostics was really small.
That's right. Yeah.
Here's the,
Yeah, the runtime overhead. They technically say, I mean, you should be doing this for a low,
mhm.
uh, I guess, trigger operations of some kind. Probably don't want to.
Right. You don't want to do this in like how we normally use it in like um, cloud
Network,
networking,
yeah,
which is
network
like
packet,
literally
yeah, like every
all
TCP packet, every packet,
every
yeah,
single packet, right? But for this, because the system is so constrained, it's more about using it for instrumenting, like when they take measurements off one of the devices that the microcontroller is connected to, right?
yeah,
One of the voltage lines or something, because it's ultimately these IoT devices are basically telemetry devices to some extent. They're
mm,
watching something, either like an accelerometer or some sort of voltage line, right?
yeah,
And so yeah, so the big thing, like they describe this as sort of like the inverse of the how we're normally thinking about using eBPF in Linux, right? Like, because we think about it's like it's a big iron and it's doing a lot of functions, right?
mm,
And we're trying to squeeze as much efficiency out of what is essentially a well-provisioned piece of iron, right? And
yeah,
they're thinking this is thousands of under-provisioned little CPUs,
mm,
right? And they
yeah,
want, and they're all doing one function. So it's like somewhere between serverless and
and big iron, yeah,
big iron, because it's event,
yeah,
because like serverless, it's event um initiated programs, right? That's the whole point of
yeah,
like them
yeah.
using the eBPF, but it's only the business logic you need. In fact, oh, I need to dig up. I actually found their GitHub repo and I actually tried to get it to run, but my
Ah,
development environment was a little jacked. And
is this
so
Sming thing? Sming RBPF? Is that
no, they
or
had a, well,
oh these guys?
I tried to use
Okay.
the mainline RBPF, but it wasn't
Mm-hmm.
compiled. They had a, because they had to patch it, right? Because it's just because I
Yeah.
follow the trail of breadcrumbs because they started the PR process for RBPF to add this,
Mm-hmm.
and you know how it goes. It sort of gets stuck, right?
Yeah.
Um,
Always. Yeah.
Let me see if I can. I had this queued up on my Linux computer, but I moved over to the Mac and I forgot that I need to queue this up. So let me stop sharing this my screen for a second, and
Sure.
let me see if I can uh find the GitHub.
It was quite interesting. I looked at this the reference paper that rapid patch or something they were describing. That's also like something pretty interesting. Like it makes you think, right? We always think like we patch security issues, and then when
Oh
you
yeah,
patch it, there's you found it.
yeah, I found their org. They have an org. So, but I'll let you finish your thought.
Yeah, so it was interesting to hear how you have to perform a security patch, but you don't have I mean, the luxury of rebooting your system because some of these IoT devices, well, it needs to stay on. It's not like I can launch a new container here and all of a sudden it just has the new version shut down the previous, do
Yeah.
cycle my old instances and off we go.
Yeah, and that
And
brings it up
so
like
that
they call it containers, but they're not
right, they're not
really.
really containers, right? Yeah, but I think that I looked at they referenced that somebody else had done something prior to this, which was called Rapid Patch, which seemed to use eBPF to patch security holes in the kernel and libraries by installing additional eBPF programs. Because if you can't reboot your system, you can load an eBPF program to maybe fix the issue.
Oh, basically, it's like
It's
you're
like,
essentially working around the existing Linux kernel logic
yeah,
by using the
yeah,
hooks.
by using the hooks. And it's like it reminded me like you're patching an executable memory in memory, executable code in memory to make that executable work until it needs to restart by, running the new version. Because some people like this IoT folks don't have the luxury of, oh, I'm just gonna boot the device. It's gonna have to be down until the it downloads the firmware update and reboots itself, and now
Right.
it's security patch. And yeah, it may take hours, may not come back. Like it's some remote location. What do you do?
Yeah, I
So
think I think that's the point of the motivation is like they want to do the firmware that's Femto container capable, right?
yeah,
And when you do the firmware, it actually, because I looked at the examples, you have to define in the manifest for that firmware, this is the hook point, like this is the hook point that's allowed. Here's the memory, here's the location where the eBPF bytecode exists that we're gonna allow, right? And then after that, all you do is you update that bytecode that is being
yeah,
pointed to by the firmware, right? So anytime you add new capabilities, it's new firmware. But if you need to
that's right.
patch that, the eBPF program that they're using as their business logic, as their
So,
Femto container,
yeah, yeah,
then it's just a over-the-air update for
on that
that,
container. Yeah,
right? But for just that piece of data that's sitting
yeah.
inside the RAM. And I thought it was interesting. I'll go back before I go to the GitHub. I definitely thought in terms of it was amazing to me how small of a footprint they were actually able to get with their optimized uh runtime, right?
I sent you a link. I don't know if that's where you're looking for. I found this online when I was reading the paper.
Oh no,
Um,
I have a better one. Let
okay.
me just share my desktop. If I can roll to so
Oh,
this is the
future-proof
actual
IoT. Okay.
yeah, this is the actual org, Future Proof IoT. And so
Okay.
this is the one that has three or four tutorials, but they're a little bit rotten. I couldn't
Mm-hmm.
get this to work as documented because the RVP because the RBPF
Has moved
uh
on. Yeah. Right.
yeah, it's something with Git submodules. Every time I see this Git submodule, I'm always like, oh, this is gonna break for me, right? But
Yeah.
I was able so this is their multiple tutorials, and these are at least great to read through. They're actually somewhat documented. And so I was starting to understand what they're trying to do by just reading through the code. I love reading, even though I'm not great at actually writing UPF code. I love reading through existing code because then like I learn a lot just from examples,
Mm.
right? But they made the PR for Riot is actually they made an attempt to get these changes into Riot.
Mm.
Um, so it's that I want to just watch it and see if that actually gets unstuck because this is fast. I find this really fascinating. But they have four tutorials that actually sort of step through. But let me go through the one that for the that actually goes with the paper. There's actually this one. This is actually all the stuff that they show in the paper, I think.
Mm-hmm.
And so they actually have the bench example, which actually runs the benchmarks. So you can actually, and these are the ones I actually think I got working until I ran into the fact that my Fedora development environment's a little busted. But
Mm.
so I was trying I tried to move it to a CentOS box, and then I just sort of ran out of time. So, but I'm
I found Fedora much harder to deal with
oh
cross compiling. Yeah.
you can't cross compile, and but since I'm not trying to since I'm not trying to actually use an IoT board target,
Okay. All right.
you can compile native. So it's not a problem
Okay.
just for running. If I had one of their boards, yeah, I would be using like a Debian or Ubuntu VM and doing it
Yeah.
just like
Yeah. Yeah.
so I can hit the targets. But the way the Riot stuff works, you can actually compile for whatever native target you're on while you're developing
Mm.
and then cross compile. So that at least gets a flavor of the how it works, right? But And when it's native on Linux, it actually uses the existing eBPF implementation, I believe, because it's
Okay.
there.
All right.
Um,
So they made it
but
close enough.
yeah, well, that's the whole point. Like this is that the eBPF
Right.
virtual machine is actually pretty simple, right? It's like there's like 11 registers.
Yeah.
So that's what's amazing to me. Is like from what I can tell from this paper, right? They actually implemented for Riot, which is a microcontroller operating system, right? It's not Linux.
Mhm.
I believe it's just BSD or license. They created a whole new eBPF virtual machine.
Yeah. Sure. Yeah. Or
And
ported whatever that RBPF is.
yeah, they ported it and then they ran it through an optimizer loop, right? Because they
Yeah, they
used
said that how, yeah, they optimized the loop. It's pretty, well, yeah, I haven't looked at the code, but it's pretty standard, right? That you jump tables instead of calls,
right, right.
and
And so yeah,
so
their cert FS is their formal verified
yes, yeah,
implementation that was originally based on RDPF, right?
yeah.
So which I find interesting that they were actually, they make a claim. Do I make the claim? Do I highlight the claim? They make the claim that this is the first like formally verified
Yes, that's right. Yeah,
implementation,
very sure.
which is, I mean, I know they couch it as like we believe, but that's still a pretty strong claim that, they
Yeah, and it does help that it's only like what 100 instructions they said, the actual implementation,
Oh yeah,
but
yeah. In fact, it's different than the Linux implementation because I think they have tighter bounds for what's allowed in terms of total number of instructions, right?
yeah, yeah, yeah,
Because they implemented the registry set, um, and they implemented a verifier. It's not the same because they
yeah.
have different. They talk about that a little bit too about
Different
the
requirements,
differences in.
yeah,
Yeah, because they require you to explicitly whitelist what's allowed in the manifest when you're building these things. That's part of the baked in firmware, right? It's a much more explicit and honestly, this is a first cut. I mean, this makes sense in terms of the problem space we're trying to address because these IoT things are not like general purpose uh
hardware,
multi-threaded.
yeah,
They are threaded, but they aren't like general purpose. They're going to run random things. So, I they do a good job talking about the threat model and and why they're making the choices they are, but it's still fascinating. But yeah, like
yeah.
there's some definite specific differences between the Linux implementation around memory, right? But they
Verification,
still but they still had to implement the whole spec. They still had to like implement
yeah,
they still have maps, right? They still have ways to share
yeah.
memory.
Memory, yeah, yeah.
Yeah, so and but like yeah, so it's a strong claim. Uh but it is interesting that they claimed it's the first one that's been formally verified.
Verified.
And yeah.
I mean, formal verification is hard. Um,
Hmm.
yeah, it's extremely hard. There's software and tools for that, but it might
I mean
be
that's still that's still one of the knocks for the Linux implementation, right? Is that people are still concerned and why we
how
don't
safe it is. Yeah,
yeah, we because that's why we don't see unprivileged use case. It's still considered a privileged operation because it hasn't the verifier hasn't been taken through a full formal verification, right?
patient.
So the fact that they were able to do it for this, I'm not even going to call it a toy implementation. This is a real implementation for an IoT uh, problem space is actually like kudos, right? Like it's
Yeah,
actually,
for sure.
I mean, like it's fascinating because they were serious about this. Like they this isn't like a toy academic. Maybe this will work. Like they were like this seriously brings a capability to Riot to be able to do eBPF, which is I think like now I want to know more about Riot, right? As an
Yeah,
OS.
yeah,
But
yeah. It's
yeah, so
pretty sweet what they got. Like I'm really impressed by the size, the final
yeah,
size of how much it actually costs for the device? Because that's the critical part. Like, I
Yeah,
mean, it takes what, like half a kilo in RAM?
yeah. Like they
It's
go through it,
just like
and they really do a good
mind-boggling.
job of talking about other interpret, like if you wanted to get this sort of functionality, you would reach for an interpreted language, right?
Yeah,
It's like because interpreted language is effectively you're running scripts, and so you can runtime
yeah,
change those very easily, right?
yeah,
But
mm,
all the interpreters come with a ton of overhead, right?
yeah.
And they really
Memory and
they yeah, and the big thing is the RAM is, I think, the biggest critical thing in IoT, right? Because like,
yeah,
you know,
yeah.
drive
Execution
space
time, yeah. Execution
and
time is
it's
important, but at the same time, hopefully you're not running this very often.
right, right, right. Yeah, execution, but these are all underpowered. It's like they just have to run fast enough, right?
Yeah,
Um,
yeah,
because usually these things are microcontrollers, at least in my experience, are unless we're talking about networking edge things, but they're always just talking to some sort of telemetry, like GPIO kind of thing, right? And they just have to make that measurement fast enough, right?
mm,
They're barely doing any calculation. They're usually taking measurements and streaming them to something else, right?
yeah,
Like with MQT, it's MQTT is sort of the
uh,
protocol
yeah. I
for like
remember.
streamed edge data. Um,
Mm.
but they're doing if anything, they're doing a little bit of alert logic locally so they can light up a light or something, right? Uh, but generally it's doing watching
Streaming data.
analog,
Yeah.
watching an analog pin or something and taking a voltage measurement ultimately. Um, or asking dedicated like accelerometer chips what
What?
what their latch circuit saw.
That's
So
yeah, yeah. The status. Yeah,
so
interesting. Yeah.
but it's fascinating like how absolutely tiny it is right now. Is this bias, like did they like deliberately like write their Python and their WASM like
I don't think
poorly? I
so.
don't know.
No, I don't think so. Like WASM is huge.
Yeah.
Um, I mean, it may be fast because it's natively compiled, sort of. I mean, their cold start here is, yeah, it makes sense. Like it's probably compiling that on the go for the hardware
Hmm.
or something. Um, but then it gets much lower speed, something
Hmm.
similar. I mean, um,
Yeah, I mean
but
WASM solves the problem for moderate to large
yeah,
resources. Like it
exactly.
definitely it doesn't even want to pretend. I don't think their mission statement or their problem space really attacks like under provision stuff. It was never part of
Yeah.
their charter. So it's not a knock on them at all. Like if anything, it's like this is still amazing that this works at
Yeah.
all.
No, absolutely. Yeah, absolutely. I mean, the Python, again, I'm not surprised. Like first part is probably just loading the Python bytecodes and then it's slow as hell because of the VM is slow.
Yeah.
Um, although
Yeah.
that is a bit surprising. Like, I mean, I've never looked at MicroPython. The the regular C Python actually is a pretty good, decent interpreter implementation. Probably best in the business, to be honest, because they don't have a compiler or not yet. So the C Python interpreter is pretty fast.
Right. I
Um,
mean, it's sort of the oldest, right? So it's the most
yeah,
optimized at this point, right?
yeah.
I,
People have spent like years working on.
right. I
on
haven't I haven't looked at MicroPython either because but clearly, that's meant to be sort of in this space, right? So unlike Wasm, which I don't think is meant to be in the space, whereas
yeah,
MicroPython is probably they're trying to provide an interpretive uh implementation for, IoT scripting, right? But
yeah. So
so that's
surprising
probably
that
the
it's like almost 10 times slower than what they got with 100 lines
I
of
know.
interpreter.
I know. That's what's
It
like
must
that's what's
be
amazing.
that, yeah, you know what? I bet you it has to do with the size of the instructions because Python instructions, the way they load them, and probably to achieve the same thing, it just takes a lot more cycles just to
Yeah, yeah,
execute the
yeah.
pipe opcodes and load memory and do all these things.
Yeah, because it's more abstracted, right? Like
Yeah,
the
that's right.
eBPF
Yeah,
is such a tiny like
yeah,
restricted register target.
yeah.
But they did say like the I guess the one complication that they ran into when they were implementing the eBPF spec is because the eBPF spec is 64 bits and
Mm,
these devices are natively 32-bit registers. So they had to do something about that, right? Could have
mhm.
sworn I saw
I don't know
something
if I
about that.
read that. Oh yeah, there it is. 32-bit controller.
Oh, am I on
Yeah,
it? I'm
yeah. I think here on the other side of the screen at the bottom. In this paper, we focus primarily on middleware, popular, 32-bit.
Oh,
Oh,
here we
it
go.
says, yeah. So they must have done something there. I don't know if they talked about the difficulties around that. I don't remember.
Uh, I don't know. Let's see if I can actually search.
Yeah, 32.
Yeah,
Yeah, you gotta hit that button. Yeah.
yeah, there it is. So 32, and of course my Zoom screen is in the way.
Yeah.
Yeah, I totally missed the rapid patch as a thing to look at. So I'll have to look that up.
Crazy. Like I will. I looked at it because uh, the whole security thing with something we're doing at work right now. They're talking about base images and improving, patching processes and so on, detecting vulnerabilities. Uh, and it just struck me as like, yeah, for these guys, you can't update it. Good luck with that. But yeah, it's so interesting that, I mean, you think like eBPF is for extending kernel functionality. So why don't we use it to patch the kernel functionality with something slightly different that avoids
That
these?
I'll have to look that up. That sounds like a great way for me if I ever attempted that to make spaghetti out of everything. Here it is,
Ah,
registered.
right. Okay. Yeah, they probably had to mess with it.
Yeah, they talk about instructions divided into 8-bit opcodes,
Okay.
two 4-bit registers. Right.
I guess they just ignore the upper part.
Yeah, I think that's what they end up doing. But this
Yeah.
like they had to basically re-implement
Yeah.
the eBPF virtual machine, right, to handle
Yeah.
this. Like that's what's fascinating to me is like it's like they implemented a new eBPF implementation. So for Riot, like so
It's
which it's
hats
gonna
off.
be
Yeah.
yeah, it's going to be everywhere because like we know the Windows one is coming. It's just a matter of when we can actually start beating up, right?
Yeah.
Like publicly.
I don't know. Next Windows.
Yeah. And and you
If we're
know,
lucky, I think they release everything. I think there's a big version usually comes in February.
mhm.
I don't know. Like I used to work at Microsoft, uh, so I usually February was one of the times when like depends. Like they might drop a major update, maybe not.
We can't know until we know, right? Like that's the reality there. But but yeah, let me go back to the where is so this is the GitHub uh this is the GitHub for the code. And I love it when papers provide the code as supplemental material, uh, so that you can see exactly what they're doing and try to reproduce it. Like I said, unfortunately, I ran out of time because I jumped into the instead of doing the benchmark stuff, I jumped into the other repo that was a little bit rotten
Mm,
and I got stuck in the submodule thing. But this one actually compiles for me, and then I just ran out of time. But these are the actual examples that they use.
mm,
Um, and what's interesting is they, they have their own branch of Riot here, and uh, that actually has the eBPF implementation that they
Patient
developed.
added. Yeah.
So, which I find, and what was the license for Riot?
It's LGPL, I'm pretty sure.
Oh, it's still GPL. Okay, so
It's LGPL. I think it's LGPL.
oh, it's LGPL. So
Yeah. Yeah.
not not
Not
terribly
too
different.
bad. Not yeah.
Like it's not an interesting it's not like a interesting discussion about how that works, right? So yeah, so so they so it's very similar to the Linux. So you could talk about this in the same way that you talk about having to do Linux stuff. But yeah,
Yeah. It's pretty cool. Um, what do you
if
think
I
the
had one of
chances
the
are to to merge this in Riot? I mean, I don't know. Like, I always find like contributing to OS is probably the hardest ever.
uh let me I found the PR and I don't want to jinx it, but this is the problem with open. It's a difficulty with it. I don't want to say a problem. It's there just isn't enough time, right, to maintain some of the stuff. There's always more features than man hours, right?
Yeah.
But if I had any influence at all, I'd be like, this is huge. Like this is a huge capability, I think, uh, for an iOS uh, OS. And if there was like I don't know how big the Riot community is, but if there was like a conference, like this should be like a big thing to get
Just
people to talk about. Let's
like
see if I can. I know I found it. There it is.
yeah,
There it
nice.
is. So like I don't I'm not gonna poke anybody in the eye about it, but it's you put it in March and they didn't say no. It's just a
Yeah,
matter of, in fact, they gave them some feedback on the implementation. So it's just the process, right?
yeah.
It's never as fast as you want to see. But from my point of view
Well,
as an
especially adding a
outsider,
VM, not fixing
yeah,
a bug, right?
yeah, like this is a significant capability, and it seems to be like a huge value win. Uh, and if I had one of the supported boards, I would be playing with this right now. In fact, I'm gonna I'm gonna
You're
see
thinking of
I'm gonna
doing some weekend
like
shopping.
yeah, like over the winter break, right? I'm gonna be like, okay, I could
Yeah.
either play Switch or I could try to play with this and build an IoT device for my home network that does something useful via
eBPF.
this eBPF implementation. Because I'm trying to think, is like, because like one of the things I saw is like in one of the examples, I wish I had it queued up, but one of the examples I saw in the tutorials I was trying to get to run was it basically exposes an HTTP endpoint on the IO on the network of the IoT device, right? And you hit that as soon as you hit that endpoint, right?
Yeah.
It ends up triggering the eBPF program, right?
Yeah.
So
Yeah. Exactly. Yeah.
so it's very much like serverless, right? So the
Yeah.
idea is like you hit the endpoint, and I could build something like I don't know, like a temperature gauge or for my smoker or something, right? That's on
Okay.
the
Okay.
network, and I could hit it that specific endpoint, and it would read the temperature using eBPF instead of sitting there in a just in a loop, right? Or and do it super efficiently, right? And that's the kind of thing like I can already envision how to build something that I could like play with for myself
Yeah.
if I just had one of these boards, right? So, which is like I said, I if there was a conference for Riot, I think I think this should be talked about and get some mind share around the maintainers to move this forward
Mm.
because I think it's just the it's just amazing how what the performance is for this, right?
Yeah,
I mean, yeah, nothing beats native C, right?
it's true.
But but
Yeah, but go change that. Go change that.
but now you don't have to like update the firmware for the whole
Yeah,
blob. You can just
yeah.
update this specific business function, right? So now you can have a whole bunch of these tiny little business functions and update just one. And then I really want to talk to the author about the diagnostic, like some of the use cases they envision, because like I think I think this is clearly more than just like a toy. Like there's definitely some specific use cases that they're attacking
I think pretty
beyond this
much like
paper.
it wasn't just for a paper. Since they're trying to
Right.
merge this into Riot, they're serious about this.
Yeah.
Maybe they have a company in the back of their minds thinking about, you know, patching
Yeah.
IoT devices is a big thing, right? When you think about it, like one
Oh,
of the
it's
biggest things we
huge.
hear is like you take over IoT devices don't get patched, you take them over and you do DDoS attacks and whatnot.
Yeah, that's why that's a good point. I think that's why they talk so much, like they go deep into the threat model, right? As right after the motivation. So it'd be it'd be really like a malicious tenant. Like I've never thought about a malicious tenant on an IoT device. I've never even thought about that. Because
Well,
like when I
yeah,
was working on it, like we were just they were just little thing Bluetooth things, right? That
yeah. Well, I think it's mostly the network devices.
yeah.
They got easily hacked and
Yeah, once they're Wi-Fi or
yeah,
devices,
or
right? Then
yeah, that those get
but, but why would anyone malicious like they're so underpowered? Like what can you do with them? I guess if you have a billion of them.
yeah. You send requests from each one once in a while, and you DDoS.
Yeah.
Yeah.
Well, let's see if there any other notes I want to talk about. Like I said, like I saw this title and I was fascinated because I have history with IoT, but as I read it, I'm like, I just kept finding more. I didn't even see the rapid. I got to look at that, the rapid patch, because that seems cleverly insane. Cleverly insane.
Very much the same. They claim they can patch 90% of vulnerabilities, apparently, with rapid
Hmm.
patch of the
Hmm.
ones, the CVEs that get published to these IoT devices. Uh,
Hmm.
they claim, like, I don't know if that's the reality, but the claim on the website is that they can patch 90% of it with
Well,
eBPF, deploying eBPF programs.
maybe, yeah, I'll definitely look at that. Let's see, was there another? Yeah, I just noted the big claims.
Yeah, I mean, it's slower than C for sure. But
Hmm.
if you look at the start time is minuscule. It's like 1 microsecond. I'm not sure how
Yeah.
they even measure that. And the memory overhead of the program is nothing. I mean,
Well, it's the trade-off between being able to have uh updatable business logic separate from the firmware. Other because like if you do the native C, like you're basically pushing a full firmware every time, right? And that's
well, yeah, that's the
just
downtime.
ridiculous.
Yeah,
Yeah.
yeah, that's
Whereas
downtime.
here you're able to target specific functionality. So that's the trade-off. It's it's a little longer to run, but it's not too long, and it's a little but you're doing pretty well in terms of RAM size too, right? So
Yeah.
so it's a good.
And WebAssembly, I mean, then the memory overhead is just never going to be acceptable. I don't know.
Oh
I
no.
think they used it as an example because it was faster than theirs for execution time, but the the memory overhead will never be acceptable.
Right. I think I yeah, I think you're right. I think they provided that as sort of uh
Somebody
best
said maybe to
case.
them, it's like, what about
Yeah,
WASM?
yeah.
It's like
Yeah. What
you
about
could do
WASM?
this. Yeah, what about WASM? Why are you guys doing that? Right. Um,
But the memory is is definitely not.
64K for a program? Come on, like on an IoT
Right.
device. That's,
Right.
I don't know,
I mean, storage is
1 meg, 1 meg.
yeah, the RAM is the killer. Like the ROM size doesn't matter. Like storage, like disk storage is nothing now, right? But um
The
thanks
RAM, yeah.
yeah, thanks smartphones, right? Like soldered disk is cheap, but
Yeah.
RAM is still sort of your most expensive thing, I think. Okay, so I've monopolized, I think. I've talked a lot. Is there anything specifically that you saw that was really interesting? Other than the rapid patch, which was a good catch, actually. That I totally missed that.
Yeah, like I said, like I started thinking of containers in terms of containers, like Docker containers,
Hmm.
and I sort of realized it's not that. That was that was interesting that they, but it's possibly, I mean, yeah, it's a femto container, so uh, for us working with Docker containers has a different connotation in our heads. But I was expecting like how do they put an actual container? I was thinking C groups and stuff. What? And then, but it's interesting that there's a C program technically that's get deployed as a standalone, sits there, and then it's triggered. It's almost like a function, really,
Right.
when you think
Yeah,
about
they
it.
talk
Yeah,
about that they mentioned it's very much like how serverless
works. Yeah,
architectures work.
it's a function, right? It's
Yeah.
it's a function that's triggered on an OS event of some kind, and
Like a connect. Like it's literally a
yeah,
socket connect can
mm,
trigger this, right?
yeah, yeah, yeah.
Which is
Pretty
fascinating.
clever
Like, what if someone actually built like an actual serverless like service architecture that used this
with this.
approach?
I don't see why not. I mean,
Like, like an AWS Lambda that's eBPF function powered
from
versus like Python powered.
I don't see why not. I mean, I don't know. Like, it's interesting, right? Because you could fit more of them this way.
Well, it's super. I mean, it's I mean, but for big iron, you don't need to worry about this trade-off, right? Like,
Sure. Yeah, yeah, that is.
I mean, unless there's a reason why a serverless architecture would need to worry about RAM consumption. Um, and I think for something like an actual service, you know,
The least of
is
your worries is the runtime.
yeah, but it's still way better than like a Python runtime in terms of speed, right? But
Yeah,
but
and
you
it's
but
safer than C. Yeah,
right, right. Um, but would you just at that point you just use WASM, I think, because
I guess so. I guess so. It would be faster.
yeah.
Not the cold start though. You still got to JIT everything.
Oh
Um,
yeah, yeah. Yeah. The cold start is it's that's amazing. And like for IoT, that's actually a huge win too.
I think so. Yeah.
Yeah.
Um, the cold
But
start
it's interesting to think about. Like you could build a serverless like general purpose like
architecture with this.
network.
Yeah. Yeah, for networking for sure. Um, makes you wonder of those folks that work on networking devices. Maybe there's something there
Well,
that
I
lets.
think yeah, you mean like microcontroller based network
Yeah.
devices, not
Yeah.
not something that's running like a little Linux already.
Yeah. I guess so. Yeah. Microcontroller, custom hardware for certain things.
Yeah.
But I don't know how many do that these days. I think
Yeah.
most of them just grab off the shelf components and build.
Right. Yeah, because like, you can getting a little ARM Linux now is not a big problem. But these are more like I said, I think this is more aimed at telemetry boxes that are sitting on your assembly line watching some piece of equipment, right? And they're doing
Yeah.
two or three functions of business logic, right? and
Yeah.
you just want to hit them on the network and have them do the event when you want it. So, but yeah, like if I can get the author on and talk about it, maybe there's some use case that they haven't mentioned here or something specific that they're it's really driving this, which would be interesting to talk about. But yeah, so it's been almost an hour. I think this has been good. This is a good,
Yeah, it's a really good paper. Thanks for, I mean,
yeah.
definitely opened my mind about what's possible beyond what we currently see in the eBPF land.
Yeah,
Um,
that's one of the things I want to do with this. I actually want to try to find the papers that are like a step to the left, right, of where,
mm,
you
mm,
know,
where we
the
are,
main
yeah,
thrust of yeah, the main thrust of industry is because it's there's so much capability, and I think the people working in the academic area are the only people who can like really poke at it, right? They have the
yeah.
ability to step outside and do a little exploratory work outside of like, you know, where the thrust of networking use is or security observability stuff is. But this is
I was
real.
gonna,
I guess.
I mean, maybe it's a little bit off topic, but I find that even like small devices, I mean, I think we're very much spoiled by core and BTF symbols and existence. And
Hmm.
I found that even like Raspberry Pi OS just got recompiled and like kernel to get BTF symbols to be there and build with some developer quality. It's sort of BPF. I wish they didn't do that. I don't know. Maybe it's just the storage overhead. They're thinking about, oh, this is just going to be extra.
Oh, you mean
Um,
like the kernel that the default kernel doesn't have the necessary configuration to
yeah,
support.
yeah. It doesn't have the BTF symbol, so then you can't really program with core
Hmm.
eBPF, which is much nicer than what we had before. And so it's a struggle. Like you can go faster and build something much better, um, but then a lot of stuff just doesn't work. And then you're like, well, okay, now let me rebuild the kernel. And just a colleague at work was saying like he got this risk board and risk 5 board, and he was like, oh, yeah, I'm gonna try to build some BPF stuff on this. And I'm like, oh, does your kernel have BTF symbols enabled? No. Well, okay.
Well, maybe
We
well maybe we need to find a Raspberry Pi conference and
and talk
evangelize
about it. Yeah,
and
evangelize.
and
Talk
talk
about
about it.
it because yeah, because it's I mean it's orders of magnitude harder to write anything without core relocation enabled,
Right.
and a lot of the stuff that I like about the Cilium tooling just uses it, and it's like, damn it, now I can't actually write it this way. I have to write it this way, and it's sort of um But I don't know, like maybe it's just a size thing. You know, like they have this extra file on disk and oh, it's a Raspberry Pi, so I should be as lean as possible. Um, it's interesting because most of the Mac users can't use it too on Docker because of the same thing. The Docker shim VM that's running on Mac
Hmm.
doesn't have BTF enabled. So there's a brand new project now. I think it's called Kalima or something that actually provides this for Mac users. That it's gone so far that they was just yeah, I can't do this because you're limiting me so much about what I can do with BPF because you don't include those BTF symbols in your kernel.
I
Um,
should check and see if the Podman desktop has that same issue. I haven't checked on the Mac yet because I've been trying
okay,
to use Podman more and more instead of
then
Docker.
Docker. Yeah,
Yeah.
let me send you. Somebody found this on just recently, and they're like telling Mac users, um, yeah, you guys should be using this instead because, it's better than VMs. And it's kind of interesting. Let me see if I can find it. What's the project name? I'm probably mispronouncing it, but yeah.
Oh, this is fodder for Echo actually. So I'll look at it and bring it back up.
Yeah, so there's this product over here that actually, uh, it's a
Huh.
replacement for Docker, and it actually does support BTF symbols. So then every BPF developer loves this instead of because Docker on Mac is just impossible to.
Let me,
Uh,
there's it right there.
yeah.
Well,
Um,
cool. So I will definitely look at that for my own playground stuff.
I mean, I'm on Linux. I don't actually have the problem, but we
Yeah,
have a
yeah,
lot of Mac users and they love their Macs, and it's like, I mean, that's why I
yeah,
have sound issues and webcam issues and
right. That's why I do the
all the,
meetings. I try to do the recordings on a Mac, but
yeah,
all the other stuff I do, I have like a little home lab full of Nooks, right, running
yeah,
Linux, so I can
yeah.
have multi-node stuff on a network. So, but yeah, I'll look at this, and that way, hopefully, this will.
Yeah, and so these guys found a sweet spot, and they're providing a Docker alternative, which actually has the shim thing built with BTF symbols, so we can actually program. Um,
Cool. Okay. I think I'll leave on that. That's a interesting find. Maybe I'll actually bring this up in like Echo office hours when I have to do my.
yeah, I think we should really evangelize and actually tell them that it's not bad. You want BPF everywhere, you probably should be, adding this to distros. Make it enable
Yeah.
by default. Come on, make our life easy, right? I don't know.
Yeah,
Um,
that's an interesting discussion. And I mean, especially with the Raspberry Pi, it would be interesting to know exactly. I think you're probably right about why they chose not to, but but that's just a trade-off argument, right? So maybe it's
how
time
much
to,
really is it? It's not that
yeah,
big. It's not a couple of megs. I don't know, like something like that. It's really you're throwing away a lot of functionality, at least for BPF, and it's space we care about by
right,
not having that file sit on disk there. It's not like you're shipping VM Linux uncompressed or something.
right, right, right.
um, cool.
Okay. Well, I think I have a I have the next reading group. It'll be this time, but at the last Friday of the month.
I
Uh,
think it's October 27th or something. Is it something
uh,
like that? It
yeah, yeah,
just
yeah.
came
It's
into
a
my calendar. Came into my calendar the other day.
um. I think initially I had a meetup reference that was re- wrong. So one of them's wrong. The Thursday one's wrong. The Friday one is correct. Now the one that the meetup for
But
Friday. I
it's
gotta
this unleashing unprivileged eBPF, right?
Yeah, 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 yeah,
Okay, yeah,
yeah,
that
yeah. The
looks pretty cool.
27th.
Yeah, I wanna, I
Yeah,
wanna, I wanna be there for that. Yeah.
and I actually think the unprivileged thing is also sort of a little bit outside of the normal box, right? Because we get into questions of, how secure is it, right? Like I
Yeah.
know there are some use cases still like in the wild for unprivileged, but they're very, very narrow, right? Right now. But when I was looking at that paper, I actually went down the rabbit hole a little bit and found some
Mm.
in the references the LWN the Linux Weekly News um, site had some great discussions around this, right? And there's still a couple of people who are trying to champion unprivileged, but there definitely seems to
Mm.
be some
Minority.
resistance now. Yeah.
Yeah. Well,
So
it's it,
it'd be
it's
interesting to
it's
see
a,
if this comes up in
mhm.
plumbers. I want to see if there's any sort of talk about unprivileged in the upcoming Linux plumbers too.
Oh,
Now that
okay.
this,
When is that?
I think I think the schedule just out. I think I think they had CFPs. I think maybe that's just finished. I have to go back and look, but we can talk about that in the next discussion
Yes,
because it's
sounds good. Yeah.
great.
Perfect. I'll
So
have a good. Yeah.
thanks for joining me. I hope to see you in a couple of weeks.
Yeah. Be there. I'll be there. All
Great.
right.
Yep.
See ya. Bye.
Bye.